So welcome to all. In this video you will see a cascade method of 3 cylinders. So in my earlier video I elaborately explained about the 2 cylinder how it actuates. Now we will see 3 cylinders. 3 cylinders, 4 cylinders, 5 cylinders you can use cascade method easily compared to any other complicated methods. You will learn the complicated methods when you are going at the PG level. So now this is for 3 cylinders method. Okay. Similar to the 2 cylinder method, the basic everything will be the same for 3 cylinder also. That is to design a circuit. So we should remember 4 conditions. First one is safety, second one is efficiency, third one is performance of desired function, fourth one is cost. So I will repeat, these 4 things has to be keep in mind to design any pneumatic or hydraulic circuits. First one is safety. You should not compromise safety on our main machine or equipment, anything like this. So men should not get endangered, and your machine should not broken, and your piece also should not get broken. So safety should be the first. You should not compromise with the cost. Second one is performance of desired function. Okay. So it has to do the work what it is meant for, what is designed for, that is for performance of desired function. So third one is efficiency. So without any leakages, it has to be do. If you want to lift 10 kg, it has to lift. That is what performance of desired function. Fourth one is cost. So cost also we should take care of. That is how much you can reduce the circuit size, the number of balls, connections, complications. If you reduce complications, the cost will automatically reduce. That is what the fourth condition. So for this only cascade method is highly preferable than any other method. Okay. Here it is given in the words it is given as A, B, C. 3 cylinders are given. The previous video I explained about only the letters. Now it is given as a word. So now you have to convert this wording forming into letters. Okay. So the words it is mentioned, 3 cylinders ABC are used in the automatic sequence of operation. A cylinder extends, B cylinder extends and retracts, C cylinder extends, A cylinder retracts, and then C cylinder retracts. This is what my operation is given. Okay. So I am going to write the words into a letter form. That is A cylinder, see here, A cylinder extends. So write A plus. I am giving the letter plus for extension and minus for retraction. Then B cylinder extends. B cylinder extends B and retracts. So once B extended, it is retracted also. B cylinder. Then C cylinder extends C plus. Then A cylinder retracts A minus, and then C cylinder retracts C minus. Okay. This is what the operation. It is written in the letter format. Okay, I am not to change the sequence. Any of the sequence should not be changed. That's what main objective. Then first I told 5 steps. First one is forming a group. So to form the group I told I should have minimum number of groups. Second one is no letter should not be repeated in the same group. Okay, there should be minimum number of groups, and no letter should not be repeated in the groups. That's what the 2 main conditions. So I am going to start the group now. First I am going to write A plus here, then B plus. So B minus I cannot write. So as per the rule, no letter should not be repeated. So I am going to start with A plus and B plus as first group. So group 1. Then I am going to start B minus, C plus and A minus. So these 3 letters can be included in a single group. So this is group 2 and C cannot be included here. So C is repeated. So C is allowed to group 3. That is AB is the first group, B minus C plus second group. So B minus C plus A minus is the group, and C minus the third group. Now my objective is I want to reduce the group. So now it is 3 group. I have to reduce the 3 group to 2 without changing the sequence. Without changing the sequence, I have to reduce the group. So what I am going to do is I am going to bring the C minus into the front. C minus into the front. So now I can write this group as a C minus A plus B plus like this. Now also I am not changing the sequence. Once C overs only A is going to start. Okay, I am not going to include the C minus into any of these vectors. Okay, now also after C minus, A plus has to carry out. Here also C minus, A plus has to carry out. C minus, A plus, B plus. So B minus, C plus, A plus. Now you see the group, no letters are repeated. You can see C, A, B, no letters are repeated. Here is group 1 and B minus, C plus, A minus. Here also no letters are repeated. So group 2. So this is a group 1 and group 2 like this. So first rule over. Now you go to the second. Second one is you have to find some basic elements required for the cascade method. Now you have to find out what are the basic elements required for the cascade method. So this is a basic elements required. Yeah. So first we learn this before going to calculation of the rules formulas. Basic elements means elements altogether is double acting cylinder. So I am telling you basic elements required. We will see how many number of elements required for this next system. So is the double acting cylinder is required. So normally double acting cylinder is used for our any operations instead of single acting cylinder. Okay. So several acting cylinder can be retracted or extended. So at will. So this will be used. So each double acting cylinder will be requiring 2 limit switches. That's called 3x2 limit switch. This is spring operated limit switch. So it is a 3x2. So like the dash and roll, you are having 2x2, 3x2, 4x2, 5x3, 5x2. Lot of walls are there. 5x4. Here you are using 3x2. Yes, spring actuated DC wall. And each cylinder requires one DC wall. This is 4x2. So here also you are having 2x2, 3x2, 4x2, 5x2. So lot of walls are there. Here you are using a 4x2 wall. 4x2 means 4 ports and 2 positions. What is in the port here is it will have a lot of 4 openings here to the fluid to mode. 1, 2, 3, 4. And can operate in 2 positions, right mode and left mode. So it is called 4x2 DC wall. So it comes under pilot operated DC wall. What is pilot means? So having several number of operation, manual operation, lever operation, that is plunger operated, lever operated, lot of operations are there. So here it is pilot operated. This is a pilot operated. So this will be pilot operation. That is pilot means fluid, moving the DC wall with fluid. Okay, either left or right. So here having pressure lines. This is called pressure line you have to draw. We will see how many pressure line requires. And here I have one group changing wall, cascade wall. So this is also 4x2 DC wall. You can see similar to this DC wall. So this is the main wall that changes the group from one group to another group. Okay, that is our group changing wall. So you sometimes may need 1 or 2 based on the calculation. Okay, these are the basic elements required for our design of DC wall. Now we see the rules. Elements require calculation. Initially you have found out what is my group 1 and group 2 decided. So no letters are repeated in group 1 and group 2. So you have to write like this. Then first you have to find the number of pressure lines required. Number of pressure lines required. You see here how many number of pressure lines required. So number of pressure lines required based on number of groups. Since you are having here also you are having 2 groups. So and require 2 pressure lines. Then number of limit switches. So each cylinder requires 2 limit switches. We are having 3 cylinders, so we need 6 limit switches. So 2 into number of cylinders. So you are having 3 cylinders. 2 into 3 equal to 6. Then you have to find out how many direction controls are required. Since you are having 3 cylinders, each DC wall requires one. Each cylinder requires one DC wall. So 3 DC walls are required. Number of direction control walls equal to number of cylinder equal to 3. Yeah. Then last one is number of group changing wall. That is number of cascade wall required is that is equal to number of groups minus 1. You are having 2 groups. So 2 minus 1 1. So you are having 2 group walls. That is what my initial calculation. So if you are doing any mistake in this calculation, all your circuit will not come in correct way. So make sure that you should not forget this formula before going to change wall. Okay. Now you see that we will go for a connection. So we have seen all the rules and regulations for the formulas. Now we will go to the drawing the components. So take the landscape page in the paper, that is in the exam hall itself. Take the landscape page, don't go for the portrait, since you have to draw 3 different cylinders in a horizontal manner. So use the scale and pencil to draw this DC walls, and you use multiple color pencil also in the final to show the difference in a different group 1 and group 2 changing. Okay, as per the formula, so we need 3 cylinders. First draw 3 double angle cylinder A, B, C, give the name A, B, C, and put plus minus at both the ends. Plus minus at both ends, that means plus represents extension. If you give input to this side, this will be extended. If you put input to the left side, this will be retracted. That's the meaning of plus and minus. So put plus and minus to all the 3 cylinders. It's the first step. Second, each cylinder required 2 limit switches. So that should be a 3/2 limit switch. So draw 2 limit switch for each cylinder. So draw it at the, near to the back end and front, somewhat distant at the another limit switch. Similarly, draw 2 limit switch for each cylinders. Okay. So you can see it is you should draw as a spring actuated and manually mechanically operated, and give minus A minus A plus, B minus B plus, C minus C plus. That means A minus means this is limit switch will get energized when A is retracted. This A plus, this will be get energized once A is extended. Okay. Similarly, B retracted, this B minus means once the B cylinder retracts, B minus energized, that is that it will operate and flow will be there through the wall, and B plus means this will be hit back. Once B extended, this will be energized. Similarly, C minus and C plus. Okay, this is what limit switch. Then you draw 3 walls, 3 dash control walls, 4/2 dash control walls as per the formula. Each cylinder requires 1. So 1 for 1. For 1 cylinder, 1 wall. Okay. So draw pilot operated 3 dash control walls. They give the name VA, that is valve A. Wall B belongs to B cylinder, wall C belongs to C cylinder. Okay. Then, so make sure that the output of the cylinder has to go to vent. There is a pneumatic, there is no reservoir. So draw a small dotted line as to the reservoir. Okay, and you put the high pressure line input here. After input here, you can put B or P like this. Then plus and minus you put. This plus minus represents, if you want to make the beam to extend, you have to give the input to this side. That's what it represents. So for clarifying or understanding, you have to give the initial markings like this. So if you want to extend the B cylinder, you have to give the input through this side. So it is represents plus here and minus here, for easy to draw and connect the lines. To draw all the cylinders, you make plus minus and plus minus like this. Okay. Now, as per the rule, you are having 2 pressure lines. So draw 2 horizontal line, 1 and 2. So and mark it here as group 1 and group 2. Group 1, group 2. And last one is cascade group changing wall. So this is a group changing wall, draw a group changing wall cascade. And so this is a low pressure line walls. So this will be actually low pressure line here and here and here. This will be operated low pressure line. This will be operated by high pressure line. Okay, so see the difference. Since the cylinder will experience the external load, say for clamping, we need higher load. But for moving DC wall, we need low pressure line. So usually bigger machines or JCBs will have 2 pumps which has a low pressure pump and high pressure pump. Low pressure pump can enhance this type of cascade valve and group 1 valve. The high pressure pump will enhance or will help to do the external load like this, to A, B, C like this. Okay. This is what initial argument, give the proper name. And draw write your sequence also below here. My sequence required is C minus A plus B plus B minus C plus A minus. This is what my 2 sequence required. So that is when I am switching on my cascade valve manually, immediately the C has to operate. That is C has to retract it back. C has to retract it back. So always you are drawing your ABC in the retracted mode only. You should not draw it in the extension mode. Always your piston should be at the left end. That is the retracted mode you should draw. You should not draw an extension mode. That is the rule of the design of circuit. Okay. When I am switching on this cascade valve itself, C minus has to occur. C has to be retracted. So what I do is this has to be connected here. Okay. Now initially you give some dummy lines from group 1 and group 2. So dummy lines means to actuate. So group 1 C minus A plus B plus. So from group 1 C minus, that is say the green line, C minus A plus and B plus. All the three limits should be connected to group 1. So this is a dummy line is given. That is, you can see it cannot flow. Once the limit switch energized, when it is depressed down, spring actuated, the flow will be here and goes to here and goes to here and goes to the output. Once it is depressed only, this will work. Otherwise, it will be locked here. So from group 1 has to be connected AC. Similarly group 2, see the yellow line. So B minus C plus A minus. Okay, this yellow line, that is A minus. This yellow line B minus, the yellow line C plus. That's will be initially given dummy line. Since you are not switching on operation now, since you are not started, so it has to be given connection. Okay. So what we should do is I want to do C minus. Once the switching on the cascade valve, I have to go C minus. Okay. So once you switch on here, now group 1 get energized. Group 1 get energized. Group 1 get energized, and a direct line has to be given to group 1. From group 1, a direct line has to be given to the C minus. So once the C minus hits, so this will help the C minus. This should be in always the retracted mode. Always should be in the retracted mode as the starting of the problem, starting of the operation. So directly from group 1, this valve is given connection. So minus. Okay. Now next A plus has to be carried out. Once C retracts, this will hit the limit C minus here. Once it retract back, this will hit the limit switch C minus here. So already I have given some dummy line, the green line. Once it is depressed down, the line from here will go to here, and this will go some output here. The output should help where it has to carry out A plus. See the output of the line, it has to go here and comes like this, and it goes to A plus here. It goes to A plus. Okay. So whenever you are crossing the line, crossing the circuit, you make the hurdle like this, semicircle like this, like the electrical circuit. For pneumatic circuit also you should not draw a straight line. This will create a confusion where the line goes. So you draw a semicircle line like this, hurdle line, and go for the A plus. Okay. Now this valve get about the left mode. Now this will change the left mode. So this will be moved to this port in the left mode, move to here. Okay. Now the high pressure line from here will go to here, and it goes to the piston of the A, and A is extends. A extends. So once A extends, this will get the limit switch here, A plus. This will be the limit switch A plus here. Once A plus is hit and depressed down, already I given some dummy line from here. So now this will get connected. So this will support what? This will support B plus. This will support B plus. So output of the line should be given to B plus here. From here, the output should be given to B plus. Okay, so you have to give the line like this. So output of the line should be given to B plus here. Okay, now this will be shifted to left mode. This will be shifted to left mode. Now the high pressure line from here, we go to here, and it goes to piston of the B cylinder. Piston of the B cylinder. Now piston of the B cylinder extends. B cylinder extends. So extends. After that, has to what do? You have to do the B minus. B minus has to carry out. Before that, the group is over. See the slash. Slash means group over. So what you should do, once the group over means you have to go to the cascade valve. It has to go to the cascade, it should not go to the next cylinder. So that is B plus over, that is B extended. This will give the limit switch B plus here. Already given some dummy lines, and once it is depressed and energized and connected, the output of the B plus has to go to the DC valve here. So sir, cascade valve here. See the line how it is connected. So directly it's not a straight line, and you can put some arrow also. So from where the line is going, from here it is going there or here it is going. If you have some reference, you can put a small arrow mark also. Cascade valve. Once it is cascade valve hits, now the position of the cascade valve changes to left mode. So mode is changing. So once the mode is changed, from the group, the pressure line, the group 1 all will be going out. The pressure line, the group 1 all will be going out. So now group 2 will get energized. Group will get energized with the low pressure line. Okay, no energized. So once the group 2 started, what will happen? It has to go with B minus. Once the group 2 starts, it has to go with the B minus. So directly I have to give the line from group 2 to B minus. That is, I have to give direct line to group 2 is a B minus, direct to group 2. So you can write like this. Okay. So directly I am going to give from group 2, a line has to be drawn like this to group 2. Now the valve B will come to the original position, and now the high pressure will go from here and go to the rod end of the B cylinder. So now the rod end of B cylinder retracts the left mode. That's the left mode. Once it retracts left mode, this will limit the B. This will be the limit switch B. Okay, limit switch B. What has to do? Then C plus has to carry out. Once B minus over, C plus carry out. The output of the B minus, the limit switch, the output of the B minus should help C plus. It should help C plus here. So it is connected here. The output of the C plus is getting connected here. So now what happens? C, now it has to go to the, this will be shifted back. Initially it was here, I shifted back left to position. Now I pressure on here and goes to the piston end of the cylinder. Piston end of the C cylinder. Now C cylinder extends. C cylinder extends and hits the C plus limit switch. Hits the C plus, this will hit the C plus limit switch here. What should happen? After C plus, A minus has to occur. After C plus, A minus has to occur. So I should connect the output of the C plus to A minus here. I should connect the output C plus to A minus here. Yeah, since there are a lot of lines are moving here and there, make careful in drawing the lines. So you make us use of the full page of the paper. The topmost you draw the cylinder, the bottommost you draw the cascade valve, near to the cascade valve draw the pressure line, then you make a big space here, big space between DC valve and pressure line, so that you can draw multiple of lines here. Okay. So the output of the C plus limit switch should go to the A minus, so you have to come here. So see that how you have to mark. So output of the C plus, once it is depressed, it has to come and move to here and move to here and goes to C minus. Okay, C minus. So sorry, A minus. The output of the C plus has to get to A minus. Now this will be changed to right mode once again. The impulse line from here go to the rod end of the cylinder, and A is retracted back. A is retracted back. So once A is retracted back, what will happen? The group over. The group is getting over. Okay. So what happens? Once the group is getting over, it has to go to the cascade valve. So once A minus occur, this will be the limit switch, and once it depressed, the output of this line will go to the cascade valve once again. The output of the A minus should, since the group is over. Okay. Now the performance of one set of sequence of operation over. Performance of one set of sequence of operation over. Once it is over, either you can switch off your operation, or you can continue. manually or electrically, or you can continue your Shuddha operation. This was the simple system of design. You should be careful that you have to use the scale to draw the diagram, and you should not confuse with the movement or movement of the fluid lines, and give a clear arrow mark line, and you can use multiple colors to show the group 1, group 2 variation, or you can use dotted line also. In some reference, some textbook and diagram you can see for group 1 a single line, thick line, or group 2 they may use dotted line. Okay, use dotted line also for your diagram also. So it should be made clear. So before that, the formula is very important, how you are going to calculate. So similarly, if you have multiple of cases will be arising, so you may have form 3 groups, you may require 2 cascade valve. So based on the simple same concept, you have to follow. So whether go to cascade valve 1 or cascade valve 2, the procedure will be the same for all the things. So once you understand all the problems, how easily to design your next circuit. Okay. So I will recap what you are doing so far. Once I recap, you will understand so far what you have learned. So the problem is given like this. Sometimes the problem is given the diagram format also. Diagram format also they may given. It may be a bigger passage will be given. So it will be simply you can read, you can write like this. So don't get upset on seeing the big 4 or 5 lines of questions. This will be easy. Once you read, you write like this. Simply you can write A plus. Simply you write B plus, B minus, C plus. Whatever the question given, you write it here without changing the sequence. That is very important. Yeah, the sequence of operations should not be. That is, once the clamping workpiece has to be loaded, clamping has to be done, drilling has to be carried out. So one set, group 1, example. Then drill bit has to be moved out. That is, clamping has to be removed, clamping has to be taken back, then workpiece has to be removed. This is another set of operation. Okay, that is A plus, B plus, C plus, then C minus, B minus, A minus. So for this example I am telling. Similar will have different operation will be there. For all the automation operation nowadays we are using pneumatic cylinder. For multiple of operation we are using. Okay, in the all the robotic operation, quality inspection, assembly. So lot of pneumatic cylinders are used. So how it has to operate based on the sequence you have to make. If it is properly operated, easily you can arrange your cylinders also based on the 4 conditions. That is safety first, second one is performance of desired function, third one is efficiency, fourth one is cost. Okay, based on these 4 you have to follow this. Okay, so and remember I will recollect your group changing group, how to form a group. To form the group, 2 conditions. One is no letter should not be repeated, and you have minimum number of groups. Okay, you should not form a 3, 4, 5 groups as you like. If you increase the number of groups, you may need more cascade valve, you may need more pressure lines. Okay, you should make a minimum number of groups. So letters should not be repeated. So here what I explained is, I will explain the group once again. So once I return the sequence continuously as per the problem given, then you start forming the group. So A plus, B minus, I cannot include B minus, stop with the B plus 1 group. Then you start this group 2, B minus, C plus, A minus and C minus. C minus can be included. So these 3 letters group 2 and last C minus allowed in a single group. So my rule is I have to reduce one group. So what I do is I will put the C minus here. I will put the C minus here. Once I hit the C minus here also, I am not changing the sequence. I am not changing the sequence. So now also C minus, A plus, B plus. So after C minus, anyway A plus is going to occur. Here also same. But I reduce one group. I reduce one group, I saved my cost. Cost of cascade valve is reduced. Cascade valve, cost of pressure line will be reduced. So line, everything will be reduced. So now instead of 3, I am going to 2 here. C minus, A plus, B plus, B minus, C plus, C minus. So this is the forming of group. So many students will get confused on creating this group itself. If you are able to form the group properly, so remaining will be more easier for you than you. So along with this, these four number of pressure and requests based on number of groups. Yes, we reduce the group. So two things you can reduce the cost: number of groups and number of groups. Okay, you form the number of limit switches, number of dash control word, number of group changing word. So these things, if you form, easily you can draw the one and easily score the marks. So I hope you understood the 3-cylinder method of cascade method. So we will meet you in the next video for further more cylinders design. So thank you.